Alright, so today we're going to talk about graphing quadratic functions, but this time it's going to be in vertex form. We talked about standard form before, but now we're going to focus on the vertex form. So just to review, vertex form of a quadratic equation is y equals a times x minus h squared is on the outside plus k. Could also be written as f of x equals a times x minus h squared plus k, because we remember that y and f of x are really interchangeable. They're the same thing. Alright, so let's take a look at the steps that we're going to use to graph a quadratic function when it's in vertex form. So if you need some extra time to copy these steps down into your notes, just pause the video. So the first step is we're going to find the axis of symmetry. So if we remember that vertex form is y equals a times x minus h squared plus k, we're looking at this h value. We're taking the opposite sign of that h value. So then after we have the x equals h value, we're going to find the vertex. So we plug x equals that number from above in to wherever you see x in your equation. So that's going to give you your vertex, hk, which is really similar as xy. Then we're going to find the y-intercept. So we find the y-intercept by plugging 0 into anywhere that there is x. So at this point we have the axis of symmetry, we have the vertex, and then we have the y-intercept. So we need one more point, and we're going to get that next point by taking the y-intercept and flipping it over the axis of symmetry, or reflecting it. So if you remember when we were doing standard form, if this was our axis of symmetry, and we had a y-intercept here that was 2 units away, then we would want to go 2 units onto the other side of that axis of symmetry. Then we'll be able to connect all those points, creating a smooth curve or a parabola. So let's look at an example now. We have y equals negative, and then the quantity of x was 2 squared minus 1. So our first step was finding the axis of symmetry. Remembering that our axis of symmetry is x equals h, you have to change the sign of that h value. So our h value is right here. We need the opposite sign. So that means that x is going to equal negative 2. You keep the number the same, but the sign has to change. Now we're going to find the vertex. We find the vertex by plugging x equals negative 2 in for anywhere that we see x in our function. So our function was y equals negative, parentheses, x plus 2, close parentheses squared, minus 1. So now let's substitute that in. So negative 2 is going in for x. So now we need to evaluate this for y. So remember, if you're going to do it by hand, follow order operations. If you're going to use a calculator, you better plug everything in exactly how it looks with parentheses and negative signs. So when I evaluate this, we get y is going to equal negative 1. So now for our vertex, it would be negative 2, comma, negative 1. Now we want to find the y-intercept. To find the y-intercept, that is when x is equal to 0. So just like above, now we're going to plug 0 in for x. So negative 0 plus 2 parentheses squared on the outside minus 1. When we evaluate that, we should get y is going to equal negative 5. So our y-intercept is negative 5. So then when we graph that, we're going to take that y-intercept, we're going to flip it over the axis of symmetry, and then we're going to connect all those points, making our parabola. So now let's take a look at our graph since we finished all of our calculations. First thing is that we found our axis of symmetry was x equals -2. Now remember, our axis of symmetry is always going to go up and down. It's going to be a dashed line going through that x value. So here's our -2, up and down through that number. Next, we have the vertex was -2, -1. So we'll plot that point, -2, -1, and there's our vertex. Then we found the y-intercept was equal to -5. So we'll plot that point. I'll do a different color for that. Next, we wanted to flip the y-intercept over the axis of symmetry. So the y-intercept is 2 units from the axis of symmetry. So I'm going to go 2 on the other side. And that's going to give me that third point. And then you can connect all of these points and make our parabola shape. So that one's upside down, and that makes sense because you do have this negative sign in front of your function. So that is what our parabola should look like. So let's look at another example now. This one's a special case, so our function is y equals -3 times quantity of x plus 2 squared plus 2. The reason this is a special case is because the y-intercept is going to go off the graph. So to fix that, like we did with standard form, we're just going to make a table. But just like with standard form, we always want to find that x value first, that axis of symmetry. Always what we're going to start with. So our axis of symmetry is x equals h. So we're taking that number but flipping the sign. So our x value is -2. It was +2 in there, so it becomes -2. So now we're going to make our table. And we're going to put -2 in our x column in the middle of it. So then we want 2 numbers that are smaller and 2 numbers that are bigger. So 2 numbers smaller would be -3 and -4. 2 numbers bigger would be -1 and 0. I know we're used to doing -2, -1, 0, 1, and 2 for our tables, but for these parabolas it's a little bit different. We have to find this x value first and then make our table based off of that. So to find the y's, we're just going to substitute all of those values into our function. So starting with -4, we would substitute that in as -3 times the quantity of -4 plus 2 squared plus 2. So, like I said before, you evaluate by hand, make sure you use order of operations, using calculator, make sure you type it in to look exactly like that. So that should give us -10. So then if I do -3 for my value, that should give us back out -1. So then you can do all of the rest also. Let me erase these, I got a little bit more room. So we have -3 times -2 plus 2 squared plus 2, and that gives us 2. So then we can have -3 times -1 plus 2 squared plus 2, and that's going to give us -1. So, like we've done before, these tables should start to repeat, and we see that happening because we had -1, -1. So that means down here should be -10. But that's only going to repeat if you find that x value first and put it in the middle. So now that we have our table, we can graph our function. So I've got the table over here for our function. Remember that our axis of symmetry was x equals -2. So going to -2, drawing that axis of symmetry. right? So let's plot some points. -4, -10 is not going to fit on this graph, and that's okay because we really only need 3 points to make these parabolas for now. So -3, -1 would be right here, and then -2, 2 here, and then -1, -1, and then once again that 0, -10 doesn't fit, and that's okay because we just need those 3 points, so connect them. And there's our parabola shape. And that's it.